Okay, MA089, chapter 5.5, multiplication of polynomials. Okay, this time we'll multiply a polynomial by something. So in this case, we will use distribution property to multiply a polynomial. So okay, the parenthesis b plus c. b plus c is a binomial, and this binomial is multiplied by a. So by the distribution property, we can multiply each term inside the parentheses by a, right? So this will be a times b plus a times c. So ab plus ac. So for example, okay, this parenthesis has three terms, so we can multiply each term by this binomial. So this factor. So multiply each terms inside the parentheses by 3x cubed. So this will be 3x cubed times 4x to the fourth power. And then we have a minus sign here, so put minus sign. And then 3x cubed is also multiplied by 2x. And then here's 5 plus, so plus 3x cubed times 5. And then simplify each term. So this one is equal to, from this 3 and 4, this is the first term is our product, right? Product. So we can multiply the numbers together. So 3 times 4 will be 12. Can I write it 12? Can you see it? 12, right? All right, let me put them together. So 3 times 4. Let me do one more step. And then x cubed times x to the fourth power. For the second term, 3 and 2 together, so 3 times 2, x cubed times x. And then 3 and 5 together, so x times 5, x cubed. And then from this one, you can multiply the numbers, so 12 times x to the, what do we do with the exponent? In this case, we add up the exponent, right? And minus 6 times x to the 3 plus 1, because the exponent of this x is 1, and then 3 times 5 is 15, x cubed. Alright, then finally this will be 12 times x to the 7th power minus bring it down, okay, minus 6 times x to the 4th power plus 15 x cubed. All right. So you can write all steps, but if you can skip any step, that is fine. For example, so what if I write the answer directly from here? So I'm going to multiply the first term by 3x cubed. So 3 times 4 is 12, right? 12, and x to the, okay, the bases are the same, x and x, so we can add the exponents. 3 plus 4 is 7. And the minus, so 3 times 2 is 6, and then x to the 3 plus 1 is 4. Finally, 3 times 5 is 15, x cubed. So you can write the answer right away if you don't, if you don't want to write all the steps. Okay, let's try a different example. Okay, let's multiply this. So the parenthesis has 7x and then 4y, and this is minus. So we're going to multiply each term by negative 2x. So we can write it like this. So negative 2x times 7x. And then minus negative 2x times 4y, isn't it? 4y. Because this is 4y, 4y. 7x. Alright, then this is equal to, negative 2 times 7 is what? Negative 14. X times x is x squared, right? And then for this, minus and negative becomes positive. So plus 2 times 4 is 8. And then x, y. Can you see it? Okay, I hope so. Or can we do this way? Okay, for this one, or we can do this way. Negative 2 times 7x is equal to what? Negative 14x times x, so x squared. And then negative 2 times, okay, let's use a minus 4. So negative 4 times negative 2. Then there will be positive 8. So you can write 8 plus 8 and then xy together. So you can write the answer without writing any steps like this. Okay, this time let's multiply two binomials. So binomials means there are two terms. So the first factor has two terms. The second factor has two terms. And then in this case, we will use FOIL method. Okay, FOIL means F stands for the first. So we're gonna multiply the first terms of each factor. So this is first plus, and then the outer terms. So outer term is, the x and 6 are the terms outside, right? So multiply like this. Okay, that is outer terms. And then inner terms. And then this is the inner term. Then this is the last term. So this is how it works. So multiply the first term. So first terms are x and x. So there will be x times x. That is x squared, right? And then the outside terms, so x times 6 plus inner terms 2 times x plus the last one 2 times 6. And then simplify each term. So x times x is x squared and x times 6 is 6x. Write the number first. And then 2x plus 2 times 6 is 12. And then combine the like terms. So 6x and 2x. So this becomes 8x plus 12. So this is the result of product of two binomials. So use the FOIL method. First, outer terms, inner terms, and the last terms. Alright, so let's try this product. So this binomial times binomial. So first of all, multiply these two. The first terms. So actually we are multiplying each term by each term in the other binomial. So 2x times 3x. Okay, let me write it. So 2x times 3x. So this is the first term. And then the last term, the outer terms. So plus 2x times 4 plus the inner terms plus the last terms. Can you see how we multiply this? So we are multiplying each term on the second binomial by each term from the from the first binomial. Okay, so that is equal to 2 times 3 is 6, x times x is squared, 2 times 4 is 8x, 3 times 3 is 9x plus 12. And then combine the like terms. These two are the like terms, right? So 6x squared plus 17x plus 12. Okay. Okay, now let's multiply these two. So first of all, multiply the first terms. There will be 2x times x. So this is the first terms, right? And then multiply the outer terms plus 2x times 2. So this is the outer term. All right, this is the outer term. And then plus multiply the inner terms. This is the inner terms. So this will be minus 3. So negative 3 and x. Multiply negative 3, this whole thing. Negative 3 and x. So multiply negative 3 and x. So this will be the inner term. And then finally, the outer terms. So plus negative 3 times the last term. So negative 3 times 2. So this is the last term, right? Can you see it? Alright, so this is equal to now 2x squared plus 2 times 2 is 4x. Then negative 3x. So plus negative 3 means minus, right? So minus 3x. Also this one same. Plus and then this number is negative 6. So it will be minus 6. And then combine the like terms. 2x squared plus x minus 6. So this is the result. Okay, so this section is really simple. What you have to do is use FOIL method and then solve as many questions as possible. Similar questions. As many similar questions as possible, so that you will get familiar with multiplying these binomials.